Hi, and welcome to Meetings in Math. You are here to solve two-step equations and multi-step equations, and we're going to continue to use tape diagrams to look at them. So how can tape diagrams and equations be used to represent a situation, and how can I then solve for the variable? Today you are going to need a pen and a pencil, your Jaguar Jots that starts with each bag of 5 gifts contains X pencils. A calculator might be helpful, your perseverance, and your determination. So let's get started. So you may have actually already done these problems and you're watching this video as a check, or this may be the first time you've looked at these problems. In all of them, you're going to be drawing a tape diagram to represent each situation. And then for some situations, you may need to decide what to represent with a variable. Each of 5 gift bags contain X pencils. Tyler adds 3 more pencils to each bag. Altogether, the bags contain 20 pencils. And so in this case, we are starting off with 5 bags. That means our tape diagram should be divided evenly with 5. I know they don't look even. We're doing the best we can. So in the very beginning, we're told that each bag is going to contain X pencils. So we don't know how many we have. We just know that there's X of them. So that's our unknown. But then we know to that unknown, we are going to go and put 3 more pencils in each. So we're going to add 3 to it. And that when we're done, we've used a grand total of 20 pencils. So if we were to write this as an equation, it would say, how many of these bags do we have? We have 1, 2, 3, 4, 5 of those bags. 5 bags that each say X plus 3 needs to equal 20. And so now we need to find out what X is going to be. So I'd like you to pause the video and I'd like you to try to figure this out. Okay, so now we know that we can decide what is one bag. So since we know we have 5 bags and there's 20 in total, let's find out how much is in one bag. Well, 20 divided by 5 is equal to 4. So one bag must have 4 pencils in it. So there's our equation. We know how to deal with one-step equations. So I can write my equation, X plus 3 is the same as 4. So now I can just solve my one-step equation by subtracting 3 off both sides. There was 1 pencil was already in the bag. And so we're kind of doing a combination of using the tape diagrams and using our one-step equations to help us out. Okay, let's look at Noah's. Noah drew an equilateral triangle with size of 5 inches, length of 5 inches. He wants to increase the length of each side by X inches so the triangle is still equilateral but has a perimeter of 20 inches. So again, we start with what we know. So what we know is it's a triangle. So how many sides does a triangle have? 3. So whatever it is that we're dealing with has 3 the same and they're all equal because they all started off with a length of 5 inches. And then we added X to that. And when we got done with it, when we add it together, because that's what perimeter means, is adding, we get 20. Okay, what I'd like you to do is I'd like you to write the original equation that you're trying to solve and then go find how much was added to each side. All right, now that you're back, this right here, we have 3 of the same things. 3 of the 5 plus X is equal to 20. So what does that mean? This means that 1 of the 5 plus X's is equal to what? Well, I need to divide the 20 by how many there are. So 20 thirds. It doesn't go nicely. I'm just going to leave it as 20 thirds for right now. So now we have 5 plus X is equal to 20 thirds. What does X represent? X equals how many inches was added to each side. Let's go ahead and make that one a decimal. 20 thirds. We'll round that to 6.67. So 5 plus X equals 6.67. Subtract 5 from both sides. X is equal to 1.67 inches. Once we get rid of that yucky, wow, there's a lot going on, and we change it into that one-step equation, we just go right back to what we were doing earlier. Okay, number 3. An art class charges each student $3 to attend, plus a fee for supplies. Today, $20 was collected for the 5 students attending class. This time they didn't tell us what a variable was. In fact, they're kind of leaving this out in the open. Do we even know what we want to figure out? Well, we know how many students were there. We know how much it cost per student, and we know how much was collected. So the only thing we don't know is the fees. So let's figure that out. Let F equal the fee per student, because that was the only thing that they didn't tell us. We know how many people are going, we know how much they had in all, and we know how much it costs per student. So what I would like you to do is I'd like you to make the tape diagram for this one and solve it all the way through to the end. Okay, now that you've done that, we have 5 people going in all to this. So that tells me how many boxes I need. Okay, and that's going to give me my $20. I know that I'm going to charge $3 per person going. And I also know that I'm going to charge them a fee. So they had to pay 2 different things. So now, hopefully you realized that the next thing that you had to do was figure out how much one box was worth. So if there's 5 boxes, 20 divided by 5 gets me down to 1 box. So now that would be $4 for a box. So 1 box is worth $4, but we know $3 was the cost of the class plus the fee. So we can solve this. So we know $3 plus the fee is equal to $4. So if we subtract off the $3 for the class, our fee is equal to 1. So $1 was the fee. So what does this equation here look like? 5 students that each paid $3 plus the fee was equal to $20. A lot like the first one that we did. Okay, let's look at number 4. Elena ran 20 miles this week, which was 3 times as far as Claire ran this week. Claire ran 5 more miles this week than she did last week. I want you to set this up, see if you can figure out what the variable is, and go from there. Okay, Elena ran 20 miles this week, which was 3 times as far as Claire ran this week. Claire ran 5 more miles this week than she did last week. Okay, this one's super confusing. Let's let M equal miles ran. So the thing that we know for sure is how many miles Elena ran, and that's 20. So in our N, we know it's equal to 20. So that's going to be kind of the bracket thing. What we know, though, is that Elena's going to go 3 times Claire's. So Claire's 3 times. So whatever this was is 20. But then we got more information all of a sudden. It just said she ran 3 times. So I said, okay, well, whatever Claire ran, she ran 3 times it. But then it suddenly said Claire ran 5 more miles this week than she did last week. And so then I got that new information and I went, well, wait a second. She ran 5 more miles this week than she did last week. So I did say, okay, well, I was just going to multiply by 3. Then I thought, well, maybe it wasn't just as simple as that. What I forgot to take into account is that everything was 5 more than. And so I have to take all of that I just did and I have to increase it by 5. And that's okay that I had to use whiteout and try again, because what I didn't do is I didn't read the entire problem. I just read first bit. So last week she had done M and then she did plus 5. So M plus 5 and then M plus 5. And it's all of that that equals 20. So the problem now becomes a lot like what we did up in number 2. So if we were to take this right here and then change it into the form of the equation, it would be 3 times M plus 5 is equal to 20. So if I want to know what 1 box is, I know that 1 box, M plus 5, is equal to 20 thirds. So M plus 5 is equal to 20 thirds, which we know is 6.67. So when we subtract 5 from both sides, we now know that last week she ran 1.67 miles. So M was the miles ran for Claire. We do need to be specific because they're both running miles, right? But we need to be specific that this is how many miles Claire ran. And it's actually how many miles Claire ran last week. Why are parentheses needed in each of these equations for the situation above? And I think you should be able to handle that now. And you can see it's because that was what was collected, right? And it's what we were multiplying through out. So that's it for today. This is our tape diagrams model, working towards algebraic equations, where you're really working with how we traditionally do the problems. But having this understanding really does help us understand how the equations work. I am so glad you joined us today, and I can't wait to see you in our next lesson. Bye for now, and remember, be nice to everybody because we can all use some extra kindness in our lives. Bye!